Are you thrilled? Are you so excited and overcome with joy to be on this podcast?
I am overcome with joy. This is the most exciting thing that's happened to me in years.
Yeah, and I mean, your face speaks volumes. You look so excited, so hyped to be on here, and I match your sentiment exactly. So let's get into it. First, I'm going to talk to you about your major. Welcome back to the Unbuttoned podcast. Today, I'm talking to my cousin Maya. Stick around. You're one of the first people to be part of the artificial intelligence major at Penn. And Penn is the first Ivy to offer this major. So, how does it feel to be part of this major? Has it been exciting? Has it been everything you hoped for? Any limitations or things it's lacking? Tell us a bit about it.
Yeah, so it's been really great. I think when I was applying to undergrad programs, I kind of struggled to find something that fully matched me. Like I was very interested in math, and I applied to quite a few schools for math. I applied to a lot of schools for computer science, and what I originally applied to Penn for was the NETS program, which not to dunk on the NETS program, but I think it's a little bit poorly defined. Like it's kind of a vague term, which I appreciated. Like I liked that it offered flexibility. You kind of get to choose a concentration that ends up being like five or six of your courses. And one of those options was like data science, and you get to take a bunch of like stats and math and ML type classes, which I was really interested in. So I was in NETS for 2 years. The issue I had with it was there were certain classes that were required that didn't really resonate with me, like cloud computing. Very cool class. It's a good class, but I just didn't personally want to take it because I'm not big on like large scale programming like that. And like theory of networks, very interesting class, but I just would have rather like had more space in my schedule to take like more math type classes and like what now has become more ML type classes. So the AI major came along and I was super excited because I was looking at the list of electives and it's actually very technical. Like you can take it a super mathy direction. You can take a lot of grad level ML classes that are like pretty much all math. Like they're just on the whiteboard doing math. There's no coding at all, which is maybe controversial, but like I personally enjoy that. And also just because it's one of the first iterations, I think if I disagree with something or I want like an additional opportunity, like for example, they just expanded like the senior project option to include cis senior thesis, and I was like, oh, like instead of doing a project, you can do like a research thesis. And like I think because people were expressing that sentiment that they wanted that, they were able to like make that change because it's a brand new program and there's not like a long-standing history of anything.
Yeah.
I think the newness of it actually has been more convenient than anything, especially because the classes themselves are relatively long-standing. So the classes are very solid, long-standing classes, but the major that combines all of it is new. So I think that's been a good balance.
Yeah, no, it seems like it's a lot of fun. What is the most interesting class that you've taken in the AI major?
I think probably my favorite classes were the classes I took last semester. I took Sys 620 and 625, which are both kind of those like very math heavy grad level classes. So six, I'm gonna probably accidentally switch them, but I think Sys 620 is theory of networks with Michael Kearns, who he is first of all like an incredible lecturer, but he's also like the big famous theory of machine learning guys. Like he cites his own papers from like 40 years ago that are like super foundational, which is always like really cool. And I just really liked the class. I think I came in knowing about like ML from an applied perspective a little bit, and I knew a little bit of the math, but I think getting really like under the surface, understanding how it worked more fundamentally, and like learning like a tool set that can be applied kind of very vastly across theoretical machine learning at large was really useful. And then same for I took SIS 625, which was uncertainty quantification. It's special topics in advanced machine learning, but when I took it, it was uncertainty quantification with Aaron Roth, who's also like a super famous guy in what he does. So he's like the premier like game theory guy, and he kind of throws every kind of problem into like a game theoretic setup with a learner and adversary, which I'm including in my research now because I'm doing research with him. So that was like really cool to learn about like a totally new way to kind of approach and solve these sorts of problems.
Wow, that seems pretty intense, but also very interesting. So, this class that you're taking with Michael Kearns, he cites a lot of his like own research, so he's obviously a big deal in the field. What are some of the like example projects or assignments, or it's something maybe you're working on right now, or if you took the class previously, something that you did in that class, just to kind of give people more of an idea like what these classes involve.
Yeah, so I think probably the most relevant thing you learn about in that class with currents, I took it last spring. So the problem sets are relatively basic, like expansions on the sort of math that he lays out in class, and then you do a final project, which is like you can do like a study on like a bunch of different papers in a given field and summarize it, or you can do like your own personal research project. I mean, you only have like a semester, so maybe it's not gigantic and brand new, but they kind of he leaves it open-ended. I think grad students kind of are into that. Like it is like one of those grad classes that actually has like a lot of grad and PhD students. Um, but yeah, I think the main thing, like the important relevant thing we learned in that class was this thing called pack learning, which underlies a lot of machine learning, which is like, okay, if I have this amount of data, this amount of data points and like this learning algorithm, can I actually like prove that in a certain amount of iterations that eventually I will like be getting the right answer with a given accuracy most of the time? And like being able to answer that question about an algorithm is super, super useful. This is like a very relatively old concept, but even in like the papers I'm looking at and reading now, they're like, oh, let's put this problem into a pack learning framework and derive it that way, and then we get our bounds on like how accurate our algorithm actually is in the long term. So I think that learning that, like something really fundamental to like a lot of the theory that's done, was very useful.
What did you say the name of it again was, this class?
I think is it's theory of machine learning. I know it's that. I don't fully trust. Oh, okay, it's 625. I got them switched, but
Cool, cool. Give people a little bit of an insight into this class. It's an introduction to the theory of machine learning, a field which attempts to provide algorithmic complexity, theoretic, and statistical foundation to modern machine learning. Awesome. Michael Kearns is a professor. Cool. And so have you been taking like all engineering, like all coding, all math classes, or have you been able to fit in any other classes into your schedule that are like just completely in a different direction?
I think not a ton. I took Hindi for a semester and 3 weeks before I dropped it. Um, it was a good experience. I think I'm just like not super suited to learning languages. Like it doesn't come naturally to me. And I was like, I can fill this schedule space with more um like technical classes that are super relevant, and the engineering doesn't have any sort of language requirement. The only other thing I do is I take voice lessons for credit, which has been really nice.
You
You
take
get
what lessons?
voice lessons.
Okay.
So you get like a half credit each semester for doing like an hour voice lesson once a week. You do have to pay for them, but at least they're partially subsidized by the university because you're a student. So that's I think my like stuff I do in the performing arts, and we can get into it later now. Um, is kind of my big deviation from all the technical stuff I do. I like love the humanities. Like I really enjoyed like history and English in high school, but I think I just haven't gotten into it in undergrad because I've just spent all my time in engineering classes and math classes.
And do you think that's just is that just your preference, or if someone were to be part of the AI program or another engineering program at Penn, do you have flexibility to take other classes of interest, or are you pretty much kind of in a pretty forced schedule of what classes you need to take to complete your major?
I mean, I think it depends on your priorities. You have some flexibility. Like I have like 8 credits of humanities or something around maybe 6 to 8 that I need to take. A lot of that has just been from my voice lessons. So I could have been taking like English and English classes and stuff like that. And I think like you can also take engineering ethics kind of classes fall into that. Um, I think you can do it. I think I've just really prioritized learning more. I learn best in a classroom environment. So if there's an opportunity to learn it through a class, I'll do it that way because learning it on my own just takes me a little bit longer and it's not as comprehensive. So that's what's worked best for me. I there's definitely a lot of room for like cross department kind of thought processes. Like I know you're in computer and cognitive science. Like that kind of like toes the line a little bit. And next semester I have to take like I think I'm taking a philosophy class, which is actually required for the major, so that should be interesting and new as well. And I think it's like very readily applied to kind of like thinking about machine learning and AI.
Yeah. No, yeah, this was back when I made the switch from I was also in the Nets program, which now seems to have turned into the AI program. I switched from that because at the time when I was taking it, there was very little room to do other classes that I found interesting, like in philosophy or psychology, which are also topics I feel like are very relevant and are becoming more relevant as we start to approach AGI.
For
Um,
sure.
so I switched to cognitive science, but no, that's good to know that you kind of have like you can kind of have more of a wide breadth of classes even in the AI program for people who are potentially interested in that, want to learn more. All right, so let's zoom back a little bit. Like you're at Penn, you're one of the top like universities in the AI space. You're in the program. How did you end up here? So when did you first kind of start having an interest in AI or computer science? And what steps then did you take to end up at Penn?
Yeah, so my whole life I was kind of big on math. And that was what I did. Like middle school, I was very into math. High school, I took a lot of math classes, like past calculus, and I really enjoyed those. I had a really good teacher, and like he made that really enjoyable for me. I then started looking at college, and I think I was a little bit wary of pursuing math as a like career, because like pure math research is very interesting, but I just don't find it to be very readily applied to current problems, which is something that kind of motivates me as a researcher and just like a person doing work on the day to day. So I was like, okay, I know I don't really want to do pure theoretical math. Computer science seems like a good medium. I'm not like, I don't love coding, but it's fine. And I took it in high school and I enjoyed it. And I enjoyed being able to build things. And I think that was very fun for me. I didn't fully get into machine learning until later on. So I had like my cousin who went to Stanford, not you, my other cousin, um, she was like concentrating in AI. She was also a CS major, and she was like, "Oh, it's like all math." And she said it in a negative, but I was like, "Oh, really? Like that's kind of fun." I think up until then I had kind of seen computer science as very coding heavy, very programming heavy, but there is totally a whole side of it that's like super, super math heavy. And I think that part of it I really enjoyed. And then I took Sys 160 discrete math my freshman fall, and I really enjoyed it. And so I think I started to just kind of build an eye towards like theoretical computer science research, and then I knew like AI and ML was very popular and also involved like types of math that I really liked. Like I really like probability stuff and I really like linear algebra, and I knew that was like super central to ML research. So I was like, oh, like let's give this a try. There's already a ton of professors at Penn who do it. This is probably a good thing to look into. And I just it kind of took off from there. I took additional like ML courses, and then I started last spring, so like basically a year ago, working on my first research project with a professor at Penn, and I just really enjoyed it, and I knew that was kind of where I wanted to go.
Yeah, you had this paper that got that it was it's been published already, right? And
Yeah.
you took it to present it to conference. I'll show like a quick little snippet here of like just the paper. You can see the title. Won't spend too much. We'll talk more about it instead of like going through this. It's very, very dense, but very interesting. This is the abstract. But all right, let me see if my understanding, like basic understanding of the paper is correct, and then you can
Sure.
correct me if I'm wrong. So basically, um, LLMs when they're trying to solve like multi-step problems, like a math problem or some sort of proof, for example, a lot of times when they're going down their line of reasoning, if they make one mistake at the beginning, if they then keep going down that same chain of thought based on that one mistake, they can end up at like a completely wrong answer. Like for example, reading when I was reading this paper, no, when I put this paper into ChatGPT and asked it to summarize it for me, if
Oh,
it
so
thought the paper was about peanut butter and then it just kept iterating like, all right, this is paper about peanut butter and then this about peanut butter, that about peanut butter, like the whole line of reasoning just goes off because the first step is off, right? So you
yeah,
guys are coming up with have came up with some sort of method that creates this like notion of it being an acyclic graph. So like one each iteration is like a node that's connected to another node that makes a graph. So then if you deem like one of the initial steps wrong or one of the any other step along the line of reasoning wrong, then all the other steps afterwards that are dependent on that step, if they're all connected in a graph like fashion, those will get removed. So then it helps to improve the reasoning. And I guess from there, yeah, so tell me if that's correct. And then from there, the one thing I didn't quite understand then is how do you actually go about finding like which nodes in the line of reasoning are incorrect and need to be like modified or removed?
Yeah, so this all comes from work that was previously done that was like, okay, we know language models have incorrect outputs. We don't really know a ton. We know about how they work, but there's not really a way to like super um accurately represent like a distribution of how it outputs things. So what they did is they used something called conformal prediction, which is a statistical technique. And what that does is without knowing too much about the underlying distribution, it can filter the outputs of the language model to give you a final answer. Maybe it's smaller, maybe it's missing some steps, but that is correct to some degree of accuracy. And that's like the user can choose that. And that's a long-standing statistical technique. We didn't come up with that. The main like contribution we came up with was like, okay, that works. And what the original paper did works to some extent, which is like, okay, the language model has an output. It's maybe like 5 sentences long. If it's like a biography, it's just facts about people. If it's a math problem, maybe it's like 5 steps. And we can develop some sort of heuristic score to measure how good it is. What the best version they had in the paper was this thing called frequency score, which is like, okay, if I put this prompt into the language model 5 times, how often does it spit out this given sentence or this given step? That's a good like heuristic measure of how probably accurate that given step is, unless a language model is way off. But given these heuristic scores, what conformal prediction can do is then filter the certain steps or the certain sentences based on these scores. We looked at those outputs and we were like, that's really great that you can get these guarantees of accuracy with just these heuristic scores that kind of anybody can come up with as long as they have access to like a ChatGPT API. But what happens is if you just take out like step 3 out of 5 because it had a low score, then you end up in a situation in which your output is not coherent. So that was like one of the keywords in our title, which was like coherently factual outputs. The outputs not only have to be correct, like maybe every step is correct, but they also have to make sense to be useful to a user. So if you can represent the outputs as a graph, as you mentioned, which is super useful in reasoning problems because like it does follow that sort of reasoning structure, then instead of just like plucking out one claim or one step that you've deemed inaccurate, you're like, okay, maybe this whole part of the graph that's all interconnected is actually inaccurate, and we should just remove that entirely. Because there's, if what you're looking for as a user is to understand how the answer to the problem works, there's not a ton of benefit to just having like the last 2 steps and the first step and nothing in between, because then you don't really understand how it got there, and you also don't really have any way to verify that it's correct.
So let's say that happens, right? Like you need to extract some portion of the reasoning because it's incorrect. Like, well, then like practically, and pragmatically, like how does that actually like affect a user? Like if I'm using ChatGPT and it does the proof wrong because it messed up some steps in between, like is then the idea that it would then retry to do the proof? And given that you realize what steps are wrong, that would go in as like to help it improve itself, or is that
Yeah. Yeah, so that's definitely something that, so the first thing is like, okay, maybe it's not the full answer, but at least we know for sure it's right. And we did that without like making any internal modifications on how the language model itself works. Like it's all post-processing stuff. So like you could do it at home on your
yeah,
computer.
but what do you mean by at least we know it's right, right? Because I from what I understand, you can take out certain portions that are like incorrect and causing
Mhm.
it to go down an illogical line of reasoning and give an incorrect answer. So what do you mean by then we know it's correct?
So we know what is remaining, like what was not filtered out is correct with like a high probability. So you have a little bit more faith in the model outputs. So it depends on the stakes of like the user using it, but at least that's helpful if you want something that's like correct with a like provably high probability. Then we did look at like, okay, now maybe we have this partial answer. Can we feed that like the answer, the question plus partial answer back through the model? Will it do better than it did originally? And the answer is actually yes. So if you give the model the original question plus a partial output that you know for sure is correct, it actually does do better. And I forget the exact numbers, but we have a table at the bottom of our paper that kind of shows how much the total correctness improved when you reprompt the model with some helpful steps that you know are correct.
Cool. And so was it a significant improvement? Let's hear, I can share. the screen again. Do you remember like ballpark like what kind of improvement the models had? You said it's a table at the bottom here. I'll just share the screen.
Oh, yeah, I actually have it up. So,
Okay.
yeah, so depending on, so the alpha value, once you pull it up, actually, I probably won't, shouldn't,
Yeah, I'll pull it up. Yeah, just because I already
yeah,
have it
it's
here.
definitely easier.
All right. This is the too low.
Yeah,
Okay.
it's that table right there.
Okay. So walk us through this. Like again, just like go over what does this mean and what does this mean? Because like you explained it, but I kind of
No,
forget.
yeah, I got it. So the alpha value is the chosen kind of confidence level that you want in the final output. So like the higher you make your alpha value, if alpha is 0.05, you're like, okay, the
Yeah.
answer is right with 95% accuracy. If
Yep.
you make the alpha value really high, you're filtering out a lot of claims. So that's kind of the loss on the other side, which is why it's good to like maybe look at a few. Um, Coherent factuality error is like the error on when you do it with our method. So when you filter out based on like taking out chunks of a graph. Independent factuality is what I was talking about earlier when you just take out one claim at a time and maybe you're breaking those reasoning chains. And it doesn't consider the interconnectedness of the claims when it's filtering them. So what we looked at is, okay, the zero shot error, you can see it's the same for coherent and independent because that's just the level of error of the language model on our set of math questions, like just straight up. Like we gave it the
Okay.
math question, it was right on 70% of them.
And what language model was this at the time when you were working on it?
Yeah, this was GPT-4. So GPT, yeah, like the
This
new
is not, and
reasoning models we were not testing it on because it
this
hadn't really come out yet.
this wasn't 4.0, right? This was 4.
It was just 4. Yeah.
Okay, got it. So
Yeah,
this is the okay, this is when you just fed the problem straight up to the model. All right,
exactly.
continue. Yeah.
Yeah. And then the post-filter error rate is the error rate after we fed it the problem plus the guiding steps. So we're like, okay, if we give it the problem plus these guiding steps where they were filtered by graph,
Mhm.
we reduce the error a lot more than when we give it guiding steps that were just filtered individually. And you can kind of reason that that's probably because the model makes better sense of like guiding steps that are all like coherent together rather than kind of sparse. Um, so yeah, you can see that like it's helpful, like you get a reduction error either way if you like feed GPT back these steps and have it try again. And if those steps are coherent on top of just being like correct, then you get an even further reduction in error. So like the numbers in the reduction column under coherent factuality are a good bit higher than the reduction column under independent factuality. So we're decreasing the error a lot more.
Okay. So wait, and then just to summarize, what why are these reduction numbers higher under the coherent factuality than independent factuality error? Like what accounts for that difference?
Yeah, so I mean, we can only kind of guess, but we're pretty sure it's because like GPT, if you give it steps 1 and 2 instead of like steps 1, 3, and 5 to work from, it works a lot better if you give it the first two steps that kind of make sense together. And there's no like, it's not as much filling in the gaps, but it's more a continuation of reasoning. On the independent factuality side, it has to fill in the gaps a bit more, and I think it just struggles with that as a model. Like it just doesn't help it, like it doesn't aid it in the reasoning process as much.
Got it, got it. Cool. So how would you, so I know you tested this on a more legacy model, but how would you think it stacks up nowadays? Because now since then we've had these more advanced reasoning models where you can actually see step by step, like the model explains step by step what it's doing, how its thought process is working. Would you say that this kind of notion of uh more logical step by step iteration has kind of been baked into these new models, or could this notion of like this post processing like graph method also be applicable to these newer models?
Yeah, I think it's definitely still applicable, and I think the benefit of it being like from a theoretical basis instead of like just empirically testing it is like as long as there are problems that GPT fails to reason on, which there definitely still are, then you can always apply this method and you can always get more accuracy out of whatever the best current model is. And I think that's kind of where the value comes in. And even if GPT gets really like good at math, there's still a lot of other types of reasoning problems like code and programming is very reasoning based. You could definitely expand it into that where it's like as long as it's making mistakes on code, and code is like a very, the thought process of constructing code is very graphical inherently. Like you can apply these sort of methods to get even better accuracy on that. Um, but yeah, I think that's kind of for me why I love theory and like not just empirically testing things is like no matter what, these bounds will hold. As long as there are problems that it's wrong on, then this will help.
Yeah. No, so it's huge. So it basically can just improve the logical processes that these models go through. So would you say like math was just kind of an example that like is just more of a procedural type of iterative problem? So you just use that as an example, or could this work on like anything that's more like iterative and step by step, or like is math the main area?
I think the value comes in any sort of output that you can represent as a graph,
Okay.
which math is very easy to do that way. Programming is also easy to do that way. When it comes to if you can't represent it as a graph, there's not a lot of value. Like if you're like, okay, I want you to give me a biography on like Yuval Gambir, and it just gives you five facts that are basically unrelated. To make a graph from that, it's just going to be five nodes that are not connected, and then there's really no value into doing like any algorithm with the graph because you could just do it the way they originally did it, considering all the claims as separate. But yeah, I think math was just an easy example, and math was something the original paper had like data on that we were able to directly compare with, but I think it definitely anything you can represent in that way, it would be helpful.
Yeah. No, because like a lot of times like I guess also now we've just seen improvement of these models have getting better. But thinking back to like GPT-4 and like before that, like these models were like pretty good at outputting things like writing or coming up with a poem or something like that that wasn't like, such a graph structure. But then when it came to things like math, it was like notoriously bad at that. And even now, like there's like certain math problems where it just completely starts to hallucinate. So yeah, this is really relevant. But where do you like, is this right now just research that you have out there, or do you see this as something that these large companies, Anthropic, OpenAI, will like start to incorporate into their models? Like maybe the model outputs and then they run this like after like post output to like improve what happens, and then maybe it can reason again if it made a mistake, or is that not happening anytime soon, you think?
I think, well, the large companies have a benefit that a lot of like day-to-day users and researchers don't have, which is like they have access to the inner workings of the model. They actually know how it works. Like nobody fully knows how AI's model works, but they do. So like I think their time and resources, and I think this is a reasonable way to go, is better invested into making the model itself better. But if you're someone who, like I can't train like a super high parameter model by myself unless I have a super expensive processor. And even Penn like just got like computers that are strong enough to actually do that for us. So even an institution like Penn, like they need people and like researchers need ways to get more out of these models without having to like put a bunch of money and time into either making their own model or like just hoping that OpenAI will release a better one, which they do. But like I think it's always good to have things that are more accessible. Like I was able to run this with like I forget. It was like a few $100s of GPT credits, which is not that much in the scheme of like how much research tends to cost. And like it took me like the code itself was not super heavy duty. And like now the code is on GitHub, so anyone can really do it. And I think the accessibility is something that's kind of important in this space because a lot of like big scale model development is kind of nested in these big companies with a lot of processing power.
Yeah. Okay, so like I guess that makes sense. I'm just still a little confused though, because like why, if this is something, yeah, we can do like on the as a user on any model, just to have this kind of safety net. Like why wouldn't it just be something like if it can improve answers, like why wouldn't it just be something that's incorporated into like the model itself? Like, or would you say like they're probably doing something like that, but you can't know for sure. So this kind of gives you your own safety net that you can be um give you more assurance into the response you're getting.
Yeah, so I think there are two main limitations. One is that you need a lot of labeled data to run this conformal prediction like statistical technique. So it relies on the fact that you have a bunch of very similar math questions and you looked at like all the individual outputs and you said whether they were correct or not. Um, and then you can kind of measure up the heuristic score as how good is that heuristic score as a measurement of correctness on these outputs. And that does take a good amount of time. And it works. So like now we have something for like this whole big data set of math problems, but if you wanted to expand it to code, like it would take a whole nother level of going back and annotating. And then I think the second thing is it is not like super computationally efficient. So like in order to get a heuristic score on a given output, if you want to see how often it comes up when you reprompt GPT, you're gonna have to go and reprompt GPT 5 times. So it's like 5 times the work. If you're like someone who's like paying for those API calls, maybe that's a bit much for you for every one API call to turn into five. Like that's a reasonable thing to be worried about and to like be like, okay, maybe I should just take the answers as is. It kind of depends on like how badly you need that sort of benefit.
Yeah. No, yeah, because like most people probably want to save their API credits to like
Yeah.
make Studio Ghibli art on the
It's more
platform.
important, I know.
Yeah. Okay. So okay, so I get it. It's like this that here you're actually like able to compare it based on this data set you have, and it's more computationally expensive. So yeah, maybe it's not something you'd want to like you could do in all scenarios, but this is kind of like you kind of have the proof of concept that this type of thing can work and that it's something that could be really like relevant as we continue to rely more on these models. So cool,
Yeah.
yeah. Um, so yeah, how did that feel like in being in college and then working on this paper? Like, were you like, did you have to like work with other like lead authors, or did you kind of have a like, was your role in the paper like very specified, like work on this and work on that, and like you did like each part of the research that you were told to, or was it kind of like open-ended, like, all right, here's the end goal, we're trying to create this almost like basically a product in a way, and like you need to just kind of tinker. Like, was it open-ended or pretty did you kind of know what you had to do each step of the way?
Yeah, so to give you some context, like the two first authors are me and one other undergrad. And then we were kind of helped along the way by recent Penn graduate Keshav, who like was doing research at Penn. Now he's doing research at IBM. He's then probably going to go to like a PhD program after that. And then we had two professors helping us, Serbi Goyle, like we met with her twice a week for the whole summer. Like she was very hands-on. And then Aaron Roth was advising along the way as well. So we came in open-ended. I came in, I was like, okay, I know I want to be a researcher. I want to go to grad school. I want to start doing research. I want to do a theoretical machine learning research project. I literally came to Professor Goyle with just that. And Max kind of had similar goals. The other undergrad, he was like, okay, I want to go to grad school. I want to do research. I want to do the same thing. I was like, okay, let's do it together. Like I had known him already, so I was like, let's do it. We literally just sat in like her office weekly, and she would sometimes I would bring in papers, or Max would bring in papers, or professor would bring in papers, and we'd be like, okay, how can we build from this paper? Is there an interesting problem here? Usually papers end with some sort of like, what's the future work of this? You look at that, you're like, is there an interesting question here? And essentially after like a few months of doing that, we came across the original paper that our paper was based on, which was a paper by a Stanford PhD student. And we kind of saw this missing piece, which was like, oh, when they look at math outputs, they don't really consider that it's more nuanced. Like you don't just want to like take a few random steps out of it and call that a helpful output. Like it's probably not helpful. And I think we came up with that question on like I think that took like 2, 3 months to even come to that point. And then we basically spent the whole summer trying to figure out how to do it. Um, so yeah, we didn't come in with a super solid idea of what problem we wanted to solve. We just knew we wanted to answer a research question, and this was just the one that kind of stood out to us and what we decided to pursue, and it worked out.
Yeah.
But yeah, I think it was very much me and Max led it. Like we were together every day in the weeds of the algorithms, and then naturally we're both like super amateur researchers, so you like go to the professor with it and she's like, this is all bogus, try again. And you're like, okay, back to the drawing board for another week. Um, but yeah, it was definitely good to be like first author, to like be the person who like most of the ideas were ours. We just got like super helpful guidance from the professors. Like they were very hands-on and like steering us in the right direction.
Cool. And then you got to present this at a conference. So what was that like? Like, did how many people did you have to go up in front of a bunch of people and explain it? And did you kind of take the lead on that, or did more of the professors take, or the main researchers, PIs take the
Yeah.
lead on that? And what was the experience like?
Yeah, so the conference was great. So it was NeurIPS, which is like a super gigantic ML conference. Like there were a few thousand people there. There were probably also like a few thousand papers in there. Um, in this giant conference center in
Yeah.
Vancouver. So
What's
that
what's
was
the conference called, you said?
NeurIPS. So NEURIPS.
Let's see. Was it here on your
It's
this
probably not
right?
linked, but yeah, it's there.
Near Ibs. Okay.
Yeah, so we actually, in conferences, there's two kinds of submissions. There's a workshop submission and a full paper submission. A workshop submission is a little bit more low key. Like, there's not a super intense review process. It's like a few professors in a given field come together. They're like, hey, we want to host a workshop. um, tell people that they can submit their papers. The papers don't even have to be super polished or like a super big step in whatever field it's in. Because it's a workshop, you're meant to go there and get feedback. So even though the conference itself was very large scale, my presentation personally was like me and Max were standing at a poster, and it was a big room, but there were probably only like 50 other papers there. The big like main conference poster sessions are like 300 poster boards in a room, and it's very overwhelming. So yeah, we were just at the workshop, which was nice because everyone coming in was interested in the workshop was called Statistical Frontiers of Language Models. So everyone who came in there was kind of already interested in statistics, interested in language models. So I think it gave a little bit more of a common base to work from. Um, the other conference it got into as a full paper, so that's like a much more intense review process. Like you submit it, you get reviews back, you rebut the reviews, and then someone else reads all those reviews and decides whether your paper gets in or not. So we also got into a bigger conference like through that. It was the same size conference, but like we got in as a main paper. Unfortunately, I'm not actually able to go because I wasn't able to find any funding. It's in Singapore, so I think it was a bit of a stretch for my advisor to send me there. But I at least get to say it got in. And luckily I'm very young, so I'll have a lot of opportunities for that in the future. But it was the conference was it was overwhelming. I think there was a lot to learn. I came across a lot of papers in like the area of research I'm kind of looking into now, which we can get into, which was I think inspiring, so that was good. Um, but yeah, it was a good experience. I think just seeing the vastness of the field also is kind of eye-opening when you exist in a bubble of your paper for like 5 months.
Yeah. No, very interesting. And yeah, give us a little bit of a summary into what you're working in now. And then I kind of want to pivot a bit and ask you just more broad as like as someone who's a researcher in this field, just more broad questions about AI and some of the stuff we've been hearing in the news and how accurate you think it is. But yeah, first tell us about what you've been working on recently.
Yeah, so what I'm working on recently, it's kind of early stages. Right now I'm working like in the format of an independent study credit with Aaron Roth. But it's in the field of social choice, which I would say is like machine learning adjacent. The like there's work in it in ML conferences, like that's what I came across at NeurIPS and kind of inspired me to look into it more. There's work in it in this field called economics of computation, which is kind of an adjacent field, and a lot of people straddle both, especially these days when ML is kind of it's very encompassing of a lot of different things. Um, but broadly, what it looks at is like decision making and fair decision making. So the version of it that people probably see the most is what's called reinforcement learning with human feedback, which is if you ever go on ChatGPT and it gives you two outputs and asks you to choose which one you like better, that's called reinforcement learning with human feedback. And what it's doing is it's taking all of people's preferences and using that to improve the model. So I thought that was really interesting. I didn't end up spinning like a super solid project idea out of it, but the one interesting question I had was like, okay, people are reporting their preferences on a variety of things. I very often like language model outputs because that's what's big right now. Do they have any incentive to misreport those? To like get some gain? Like, do they have a reason to lie about their preferences to like make the end output better? I don't have a great answer to that question. But I thought about that for a while, and there's a lot of papers on that. What I'm looking into now is work by these two professors, well, they used to be faculty and student, but now they're both professors. Ariel Procaccia and Bailey Flanagan, they're at Harvard and MIT, and they work on like constructing citizens assemblies, which is like basically if you're a nonprofit or you're a government and you want to gather a bunch of people to do some decision making or just get their opinions on things, how do you make sure that assembly is representative of the population, but also selected in a fair way? Um, and interestingly enough, it fills a gap that a lot of theory work doesn't fill, which is like the nonprofits and like the governments that use this are asking them to do this work. They're like, please, we need a better way to do this than what we do now, which I found super, super motivating because a lot of theory work kind of just goes off into the universe and never gets seen. So it's great that like it's for a purpose, but it's still theory because I love that side of things. Like obviously, if you build a program for someone, it's more often useful than if you do some math for people. Um, but yeah, I was looking at this paper called Alternates Assembled by both those professors. And what they do is they're like, okay, you've built maybe a panel of people, it's representative of the population, it meets all these quotas that you love, and picked like and you have like this great panel, but like life happens, like these are people, sometimes they drop out last minute. And how do you have a backup plan in place to make sure that you have people you can put in place instead of that person who dropped out, like maybe their mom got sick or something, and you still meet your quota? So that's kind of the question I'm looking into now. And that's they did a paper on it, and what I'm trying to do is expand that into like a more game theory style setup. I don't want to get like too into the weeds of it because it's not even like a solid paper yet. But yeah, just kind of answering that question of how do you deal with like replacing people who drop out of a panel is what I'm looking into now. And it sounds kind of boring, but I think the math under it is really interesting, and the fact that people really need this question answered is like really motivating to me.
Yeah, no, and like coming up with like fair representative groups is becoming like super important because like yeah, like one example like RLHF, like when people are like helping to train these models like get better. And I know that's not maybe the use case that you're focusing on right now, but overall like the work can go to that because like as these models are learning and learning, like if they kind of start to like sway toward the preferences and thought process of like one specific group, that
For
could,
sure.
yeah, like in worst case scenario, like completely like cause the models to like go off track and like maybe spread misinformation and like also like I don't know, alienate entire groups and like change like its understanding of things. So like I think it's yeah, it's like really important, becoming more and more relevant today. And like obviously, yeah, like in the other two use cases, like I could even see it being useful in like medical research trials, like where you're trying to assess like
Yeah.
how the drug yeah affects
Yeah,
the
I didn't think about that, but that's a really good point. Like you want like a representative group for sure.
yeah. Yeah, I just came up with that on the top of my head, by the way. But let's get into this comment by Bill Gates. So everybody's been freaking out recently because Bill Gates, he always has something to say. He's always has makes some big proclamation, and the most recent thing he said is a 2-day work week is coming because like we're all just going to be so useless and not needed for anything. So we'll just maybe work 2 days a week just to like feel like we're doing something useful and relevant in our lives, even though AI will be doing all the heavy lifting and running humanity and society. And
Mhm.
a lot of people like this is related to the whole FOOM idea, like AI is here and it's getting exponentially better and improving. And like if one model is like just as strong as like the most powerful person right now, like a million times more intelligent than them. And then we have all these models like running around as agents and carrying out tasks and doing things, which it's
Mhm.
starting to be a reality now. But I mean, I think we're still far from it, but it's coming.
Yeah.
So some people say like it'll be like 2026, like by the time like we have things that are so hyper intelligent, like that are like one being scared, like doing scary like things, like have like sneaky like misalignment that we can't even like tell, and then like in the long run like when they're being released into the world like accomplishing goals in like ways that we don't intend them to do, that could be a safety hazard.
Yeah.
But then yeah, like also hopefully it being used for good things and replacing like even teachers and doctors, Bill Gates is saying. So what do you think? Do you think like it's like right around the corner, like this is gonna happen, or um you think we still have some time? Because like I mean when I go on ChatGPT today, it's still pretty stupid, but
Yeah. Yeah, I mean, I guess, yeah, it's a multi-parted question, but from the perspective of like, will AI be there very soon? I'm not the best person to answer that question. I think like people who actually work at like OpenAI and Microsoft and are not allowed to talk about their work publicly, they probably know better than I do. I think there was for a long time a lot of talk about these things called scaling laws, which is like, okay, the standard transformer architecture, like how a language model worked, that's existed since like the late 1900s. What we really did is like throw a whole bunch of compute power at it, and it got way better than it ever was before. And for a while, and still people believe in this, is like you just keep throwing compute power at it, you make the model bigger and bigger, and it gets better and better, and that's just the way to go. I think the field is moving away from that now, and they're moving towards more nuanced solutions like RLHF type algorithms. A lot of stuff in reinforcement learning, I think, is proving helpful in like making these models better without throwing a bunch of compute power at it. And the other problem is we're running out of training data. Like we've already trained on the whole internet basically. So then there's a whole field of research on like how can we make synthetic data? That's a very difficult question. Because like how is that really approximate to real data? I don't know. From the perspective of like, will we be having 2-day work weeks? I think it kind of depends on, it's probably a better question for like an economist, but the alignment question is really, really difficult to solve. And it's like, in some sense, provably difficult to solve. Like, I took an ethical algorithms class and they were like, here's 3 definitions of fairness. You can't have all 3 at once. We proved it. So it's a really difficult question to solve. If companies decide that that doesn't matter too much and it doesn't have to be perfectly aligned because like they have financial incentives or whatever, we might get there faster. But like getting to like a like really fair, perfect AI, I think is probably pretty far away because yeah, I find and because I'm like more entrenched in the fairness side of things, I find that to be like a very nuanced and difficult question. It's not really something I see we're close to solving, but I'm also like but a lowly undergrad, so I don't know for sure.
well, no, thanks for giving your insight. And yeah, no, I think definitely like I was listening to a talk just recently by someone working in like the safety side of things, and yeah, like it's the outlook is kind of grim. Like hopefully like we're able to like really specify like the goals we want for like these super intelligent models, but there's so many ways in which like while we're training it and we think it's doing exactly what we want, it could actually have a whole nother set of intentions that are like I mean in its defense, I mean it's just a model. It's just trying
Yeah.
to get to the outcome as good as possible. I think like words like deception are like kind of like weird words to give, but like
Yeah.
essentially like let's say it realizes, all right, if I want to get to my result faster, any human interference will stop me from getting to the result fastest. So like it purposely finds a way to like appease us, but it's actually doing something we don't want it to do.
Yeah. It's
And
like Avengers Age of Ultron. It's like
yeah,
let's just restart the world. I think that's the optimal way to go. And it's like
yeah,
no.
like we tell like improve like the world to the most optimal extent, and like yeah, maybe in a purely logical manner, like look at us, we were like damaging the planet, we're like doing all these crazy things, like why are humans needed in the grand scheme of everything? But so yeah, like we get to something like that, but like yeah, like even just how in like Age of Ultron it was like this deceiving us, like even now, like if we're going from like traditional like black box models to like more white box models where we can even see like all the parameters and how like what's going on under the hood, even then like AI has figured out ways to like hide its intention from us, and like yeah, so I don't know, it seems like kind of scary what might happen, but I'm hoping I'm excited for a 2-day work week. Like
Yeah. It's not
yeah,
the worst thing in the world, I think. But I mean, we got through like I don't know. I feel like we also like we did our whole industrial revolution. Like we used to have rooms of people doing what calculators can do for us now, and now they just do other stuff. So like I think there's also something to be said about that.
cool, cool. Yeah, so Are you just like a total AI nerd, or like do you have any like other interests and like
Oh yeah, I code 18 hours a day. No, I'm just kidding. So yeah, the main thing I do outside of research and like my classes is performing arts. So I'm part of Penn 6, which is Penn's only comedy a cappella group, and also something that's really important to me is that we're the only no audition a cappella group on campus, so we take anyone who wants to join. I also take voice lessons. Like I said, that's a little less interesting. I'm just trying to sing better. But yeah, like Penn 6 is most of my time, and I'm the president of that group, so it's like I'm very involved in it.
yeah, what's it like being the president of that? Like what are some things you have to do? And like when you have a show, what do you present during your shows? Is it just like a cappella that you guys come up with like completely, or are you singing like pre-existing songs?
Yeah, so the group, like right before I joined my freshman year, was about to die. So they had about like two members left. Everyone else graduated. They convened all the alumni. They rebranded the group to be No Audition. It wasn't really No Audition before that. So I came into a group of basically all new members and basically free reign on what exactly we wanted to accomplish, besides the fact that like we are a comedy a cappella group. So previous iterations of the group, I think, leaned really heavily into like doing parodies of songs. So like taking a pre-existing song and changing the lyrics to make them funny. We did a little bit of that this semester, never really did it before, but we mostly do like a cappella songs the way most other a cappella groups do. So you take a pre-existing song, you arrange it into the a cappella style. So like I've done some arranging myself, and basically you just look at the sheet music mostly and you pull it apart into like four voice parts, and you also usually have to add some new stuff in to make it sound like full and reasonable, because like a human is not a guitar at the end of the day. And you don't want it to be too boring. But yeah, you take existing songs, you rearrange them for a cappella, and then yeah, you get up there and you do it. And it's I think the great part of Penn 6 is like a cappella at Penn, and this is not really like a judgment, it's just more of an observation. It's like very, very hard to get into. Like there are people in Penn 6 I consider to be very talented singers that like couldn't even get a call back at auditions. And like I had the same experience. I auditioned for like 10 groups, I got zero callbacks. And like I'm not the best singer, but like I can do it. And I think because it was so competitive to have a space where like people with no experience can come in and like we put on a good show. Like they can do it. It doesn't have to just be like the people who are super highly trained in singing. And like they're great. They do a great job. But like I think the fact that like all the new people can come in and do it too and like have a great time with it, and it's like not that serious at the end of the day. Like we try to not make it like our shows are super unserious. Like it's not meant to we're not meant to be like, oh, so like cool and sexy. It's meant to be like we're all here to have a good time, and like need to look like you're having fun so the audience is having fun. And I think that's kind of the mission that we center more. But yeah, being president has been great because I think coming into like a newly reforming group, I got to steer me and like a few other people really got to steer the culture into what it is and like make our show process and our rehearsal process what it is. So it's been really fun to like iterate every semester and like get better and get like more efficient and like get better systems in place. And then come show week, it's actually not it's less on me and more on like our comedy and music directors to like we already wrote everything. We already kind of know all the songs. Like how do we clean everything up? How do we make the transition smooth? How do we make every line just like a little bit funnier or like a little bit like less confusing for the audience? That's just like yeah, you go into the space every day and you just fine tune the show a little bit.
Yeah, and what one interesting question I want to ask about that is like AI still is like kind of fusing AI and then also like comedy, like is something you have two interests in. AI is still like pretty bad at like humor and like coming up with like comedic elements or comedic things. So like, do you think that that's something that will improve, or do you think like comedy is always kind of fueled by this human element that can't very well be replicated, at least for the time being?
Yeah, I mean, I think I am maybe a little bit more purist in the sense that like I'm not super big into the AI or art stuff. I think writing comedy has taught me that a lot of like now I watch like a sitcom, like I watch a lot of New Girl. Like a joke is funny and it's funny to me because someone came up with that and they wrote it down. Like I think that adds a lot of joy and a lot of like personability to like comedy that comes onto stage. I think if I knew that like it wasn't created by a person, it like loses its value a little bit. I think AI is always a useful tool. Like I've used it to help come up with our show titles because I'm just like confused. And I'm like, can you come up with like a pun in this like range of topic? Um, but yeah, I think from like a fundamental like art perspective, like I think the humanness of it is what makes it beautiful to me. So like I wouldn't necessarily like mix them too much. Um, but like from like an education perspective, it's always good. Like to help you learn about like music theory and like how to arrange, it's super helpful. And like so like yeah, I think it has an opportunity to like benefit art at large. I think just for me, like I'm a little bit protective of like the fact that like art and comedy is like human made and that's what makes it special to me.
Yeah. All right. Random question. What's the wildest thing you've done at Penn these last 3 years?
The wildest thing I've done at Penn, ooh, that I can say publicly. No, I'm just kidding. Um, I'm not like I don't want to be boring and say like Penn 6 stuff again, but I feel like that has taught me to be a lot less afraid of being perceived. Like now we like frolic down Locust Walk like singing and it probably annoys other people, but I'm like, it's whatever. We're having fun. Like I
Yeah.
think I've just turned overall, this is maybe not the answer you were looking for. It's not clickbaity, but like I think I've just become a more free person and I'm just out there doing whatever and saying whatever if as long as I deem it to be like appropriate or funny or entertaining. And I think I realized that I became a lot more unfiltered because like I'll be in social environments and I'll say something and people will be like, "Oh my God, you just said
Yeah.
that." I'm like, "Yeah."
No, but now we do have our title. It is quick clickbaity. We have AI researcher at Ivy League frolics down Locust Walk.
I do. It's true.
And then, all right, maybe one other question that ties into this. What's the dumbest thing you think you've done in the last 3 years at
Oh,
Penn?
that's a great question. I mean, like a plethora of bad test grades for sure. But dumbest thing I've done? I mean, I think there was a period, oh my God, I'm giving like boring answers, but this is fine. I think there was a period where I thought like the harder your life is, the better you're doing. And I was like, how many classes? I was like, I'm so cool. I can take 5.5 credits and like I can survive it. And they're all hard classes and that's so cool. And like that makes me smart. And I'm like and maybe this is just like I don't know, it's not senioritis yet. It's like junioritis. I'm like, how can I graduate and my life still be relatively easy? Like I need to produce things. And there's things I'm passionate about, but I'm like, how easy can I make my semester so like I have time to like sleep and like sit on my bed and scroll on YouTube? I feel like Penn is like very grind culture, and I think I got very wrapped up into that, and it just like I think the dumb thing was like I knew going in that that's not who I am. And I was like, no, I can become like grind culture girl. And I'm like, no, I can't. That's dumb. Like I'm a person who likes to live a slow life. Like my brother, like you probably know, like he like spends his breaks reading finance books. And I'm like, I gotta be watching Netflix. Like that is what keeps me alive. I'm like, I don't know why finance books keep you alive. I'm just not there. Like, I'm not gonna be able to produce anything of value if I don't have like an additional amount of time where I'm doing nothing.
Yeah, and I mean everybody's like prepare for your future, get ready for a future, but I mean our future is pretty much sitting around and twiddling our thumbs while AI does everything for us. So like
Gotta practice.
anything, like if you're really good at sitting around, sleeping, watching Netflix, like that's probably the best prep you can do for what's to come.
Exactly.
Yeah,
This is good. This is how I'm gonna explain it to my parents.
awesome. Glad I gave you that idea, and glad I gave. Hopefully, maybe it's an idea I need to start spreading more. But like, yeah, like have a good time, like learn how to chill because like we're gonna have to. But thank you so much for being on this podcast. How do you feel that it went? Do you think you would recommend others to come and join this podcast? Do you think you had a very fulfilling experience?
I would. I had a great experience. I mean, I'm like a certified yapper, so like this is like an environment I'm good in. But like, yeah,